Hey y'all, we're going to be looking at graphs in the quadrant 1, and we're going to be looking on how to draw a graph from a sentence, and then given a graph, how to read it. What does this tell us? Okay, so we're only in quadrant 1, which means our x and y values are both positive, and that's usually what is used most in the real world. A graph with a positive y and a positive x, or a positive independent and positive dependent. So what we're going to look at first is a sentence. We walked at a steady pace towards the museum. Okay, we're given our graph that our x value, or our independent value, is our time, and our dependent value, or our y value, is our distance. Okay, so we walked at a steady pace towards the museum. Okay, so if the museum is what we're going to, we started away from it, right? So our distance is not at 0. Our distance is far away, and we're getting closer. And it's going to take us some time to get there, so we're going to have some time there. So we're starting away from the museum, and we want to get closer, and it's going to take us some time. So our graph would look something like this. Far away distance, starting at time 0, getting closer to the distance as the time gets farther. Okay? Another graph. My sister ran away from the museum, but came back when my parents called her. Parents, plural, sorry. So, she was at the museum, she ran away, but she ended up coming back. So we're going to have a little bit of a curve in our graph. Okay, so if we're at the museum, we're going to be here, close to it. Okay, then we're going to be moving away from it with some time, right? She's running away from the museum. So from here, we're going to move away from it with some time. But then she came back when her parents called her. So she's going to get back to her distance 0 at probably the same amount of time it took her to get there. So, or it could be faster, so she's in trouble, so she's going a little bit faster to get back to that distance, okay? So we started at the museum, ran away from it, the distance got away, the time got larger also. Time is still passing, and the distance went back to the museum, okay? All right, so that's 2 examples of how you're given a statement and asked to draw a graph from that. You simply just look at your independent variable and your dependent variable and decide, am I far away, close away, how much time is going by, and adjust over a period of time and what it looks like over a period of time. Okay? So this is the vice versa. You're given the graph and you're asked to interpret it. Make up a statement about it. Okay? So we're going to go on with the museum theme. Okay? So right here, this is showing we're at a distance. Okay? Our distance hasn't moved from this point, but we're there for a significant amount of time. Okay, so our distance hasn't moved up or down, but our time is going by. So this example could be like you're standing at a painting for a while. You could say, I'm just going to say for a while. It could be for a significant amount of time, which is just say 10 minutes. It could be 5 seconds. It doesn't matter, but we're at the same distance for a significant amount of time. Okay, so this last one, okay, we have a distance away from the
Teachers, this is just a reminder, band students, do not go to 8th period. You'll need to get your instruments and report to the competition gym. Thank you.
Okay, thanks for that announcement, Miss Golden. Okay, we're at a distance, and we're starting at 0 time. So we're away from the museum. Okay, so the museum, we're not close to it, and then we start moving away. So you could say, me and my sister raced down the hill away from the museum. So raced away from the museum. So we were already away from the museum, but then we're walking out and then we raced away. Okay, so walked out, or sorry, that doesn't, we were simply started away from the museum when we started to race, I'm sorry. Okay, so this is how you read and draw graphs according to statements, okay? We'll be doing some more practice tomorrow in class. Thanks.